day, students. Welcome to week 8 of our lesson, which is scientific notation. After going through this module, you are expected to write numbers in scientific notation and vice versa. Let's start with learning test number 1. How do you write the following in figures? Let's start with number 1. 543. This is how we write 543 in figures. Next, number 2 is 1068. Number 3 is 2/10. 4 is 5,300,000. And last but not the least is 857 thousandths. Is there another way of writing very big or small numbers? So now, let's have the scientific notation. When we say scientific notation, it is a system of notation used to express very large or very small numbers conveniently. It uses exponents so as not to require the use of many zeros, which can be confusing and lead to errors. A scientific notation is written in the form a times 10 raised to n, where a is greater than or equal to 1 but less than 10. It is written as a number from 1 through 9 multiplied by 10 raised to the appropriate exponent. We can now write numbers in scientific notation and vice versa, considering the significant digits in a given number. Let's have example number 1. The distance of the Earth from the Sun is approximately 93 million miles. Write this distance in scientific notation. For our solution, we're going to move the decimal point of the original number to the left until the first significant digit to the left of the decimal point and copy the significant digits to its right. So we're from 93 million, we're going to have now 9.3. Then we're going to count the number of places you have moved the decimal point, which is 7 places, and multiply 10 raised to that exponent. So the exponent is positive since we convert a large number to scientific notation. Therefore, we're going to have 10 raised to 7. Therefore, 93 million is equal to 9.3 times 10 raised to 7. For illustrative example number 2, write 734 hundred billionths in scientific notation. So for our solution, we're going to move the decimal point of the original number to the right until the first significant digit to the left of the decimal point and copy the significant digits to its right. So from 734 hundred billionths, we're going to have now 7.34. So we're going to count the number of places you have moved the decimal point, which is 9 places, and multiply 10 raised to that exponent. The exponent is negative since we convert a small number to scientific notation. Therefore, we're going to have 10 raised to negative 9. Therefore, 734 hundred billionths is equal to 7.34 times 10 raised to negative 9. So for example number 3, we're going to write 4.7 times 10 raised to 8 in decimal form, our standard form. So for our solution, we're going to move the decimal point to the right the same number of places as the exponent, adding zeros as necessary. The positive exponent indicates a large number. Therefore, 4.7 times 10 raised to 8 is equal to 470 millions. For illustrative example number 4, we're going to write 2.51 times 10 raised to negative 5 in decimal form or standard form. So for our solution, We're going to move the decimal point to the left the same number of places as the exponent, adding zeros as necessary. The negative exponent indicates a small number. Therefore, 2.51 times 10 raised to negative 5 is equal to 251 10 millions. Remember, if the number is large and you want to express it in scientific notation, what must be the sign of the exponent of 10? If the number is small, what must be the sign of the exponent of 10? How do you change scientific notation to decimal notation? If the exponent of 10 is positive, where should you move the decimal point? If the exponent is negative, where must be the decimal point be moved? For your learning task number 2, letter A, write the following in scientific notation. For letter B, write the following in decimal notation. And for learning task number 3, answer the questions below. Express all your answers in scientific notation.